Hello, I am Harris McClamrock. I'm recording this for the Glacier Hills Senior Community. And let me begin by sharing my screen. Sorry here. I'm going to talk a bit about artificial intelligence, and in particular, why the senior community should know about what's happening in this very active and quick moving field of artificial intelligence. This is a very active time, and my intention is to provide some entree into this confusing mess from a perspective of someone who has some background in this field of artificial intelligence, but I am by no means a current expert. As I said, I am Harris McClamrock. I was a professor at the University of Michigan, and I'm going to share, as I said, I'm sharing my screen here. I started at the University of Michigan in 1967 as a professor in engineering. I was in several different departments, including areas that were related to, but not directly connected with, computer science. My areas was primarily concerned with automation and information systems and related technologies and associated mathematics. But I have some competence to assess the history of what's happened in the last 60 years in this field, as well as providing you some of my insights into the current state of artificial intelligence. I'm not going to try to give you a definition of artificial intelligence. In fact, this is one of the things that's very confusing, because artificial intelligence over time has meant different things to different people. And today, in today's current media-rich world, artificial intelligence actually does not have a single definition, and people use it to refer to a whole variety of different subject areas. This is in part because the two words artificial and intelligence together don't normally go together. And it can mean lots of different things. And in fact, it does mean lots of different things. It's a multifaceted concept. The origins of artificial intelligence are really come out of science fiction primarily. I'll say a little bit more about that in a few moments. But that's one of the things that I think many of us were first exposed to. Some of these ideas were in the area of creative writing. Artificial intelligence today, I suggest that you view this not as something that we already have, not something that's already been created, but really as an aspirational goal. And it's in that sense that people speak about smart machines, and artificial intelligence is not necessarily something that already exists, but something that they would like to exist, or that they are working to help make exist. And this is particularly true in the area of media information that's put out by the corporate world. They use language issues that are often language that's in common usage, but they use it to mean somewhat different things than what it usually means. And in particular, technologists have a habit of taking language that means one thing and using it to mean something a bit different. In fact, the words artificial, the words intelligence, are words that we use all the time in everyday language. But here they're put together to mean something very specific. And what technologists and people in this field of AI mean may be very different from the common meaning and common parlance of those terms. AI is a branch of computer science. It's connected with many other sciences. In fact, one of the exciting things to me is the breadth of these ideas, that they're important not only in technology and computer science in particular, but they're so important in the development of other sciences, and in fact, much beyond the sciences, into the areas of humanities, arts, business, law. And I'll say more about that in a few moments. And in fact, it's those potential implications for really all of society that I think motivate me to give this talk, and motivate me to suggest that every educated person ought to have some basic knowledge of what's happening in this whole area. First thing I want to begin is by saying that you're already using artificial intelligence. And I've used the word embedded here in the title to indicate that artificial intelligence may not be advertised that you're using it in some of the tools and devices that you make use of, but it's embedded into the operation of those tools. And I just mentioned some areas here. I have some bullets in different areas where artificial intelligence forerunners, things that are closely related to the concept of artificial intelligence tools, are embedded in the current technologies that many of us use every day on a regular basis. The first and perhaps the most obvious one is in the area of communications. Artificial intelligence concepts are smart systems technologies, are used and have been used for some time in areas involving smartphones, the use of sending text messages in different ways. Email, as from the beginning, embodied some of these technologies. And of course, more recently, communications technologies like Zoom make much use of many computer and information systems to allow us to communicate in ways that we weren't able to not very many years ago. And yet today, these are technologies that many of us feel very comfortable using. Another area that you use artificial intelligence in on a regular basis has to do with shopping, and areas in banking, and of course in entertainment and electronic games. These are all big areas in our corporate world that are very important into each person's functioning in the current society. And almost all of these make use either at the end user stage or in terms of providing services. Shopping, many of us shop on Amazon, but even if we shop in physical stores, the inventory systems and the sales systems and so forth are almost all run through smart systems of one kind or another. Banking is now moved very largely into the electronic world, e-banking. Entertainment, we now use much of our entertainment comes over computer networks and information systems, whether it's Netflix or regular cable systems, or even programs that we get access through over the internet. Another area that is very important to a lot of people are e-games, things like electronic bridge and other games, chess, Go, and other games. I'll mention some of those. I'll deal with some of those again shortly, but that's a very large area where you're using already various kinds of smart technologies. Driving an automobile, where we don't yet have, and may not have for some time, driverless vehicles, but we do have many smart technologies on current automobiles, things like cruise control of the engine, whether it's an internal combustion engine or an electric vehicle. Engine control is something that's under the hood. It's an area that I had some connection with myself in my own professional life. and it absolutely is essential today to the operation of automobiles. And one of the things that has been added in the last 10 or 15 years are many safety systems, whether it's backup cameras or other cameras or other kinds of sensing systems. Safety in automobiles have been improved greatly and are currently available on certainly all new cars that are being sold. For those of us who use computers on the internet, search is a very important tool that we use regularly, whether we use browsers from Google or Explorer, Chrome, or something else. That's all currently using some smart technologies. And in fact, some of the recent AI developments will, within the next few months, be added very much to the operation of these search engines. For those of us who do a lot of writing, today, most of us do our writing on a computer, so it can be saved and edited very efficiently. We use word processors to do that. Word processors for some time have had various kinds of features, auto completion of various words. So if we type the first several words or letters in a word, it may complete the word for us. But far beyond that, voice transcription and now language translation is becoming a rather more common tool that has been developed and is very important. And many more tools are coming along to help us with our writing abilities. Another area in which AI is currently being used is in voice activation. For those of us who have smartphones, we often use the words, "Hey Siri" or "Hey Google." We use Alexa. Even TV remotes are activated by our voice, and that technology is very much characterized as a smart technology. Multimedia devices of various kinds. So Google Home Nest is an example. Google Home Nest has been provided as a resource for a small group of Glacier Hills residents that are using this for various in-home features. Camera technologies of all kinds, whether it's autofocus, autocorrection, are now available and have been so for some time. A big area an important area of artificial intelligence for the future will be in the medical world, but there are already many, many medical tools that are available. Things like radiological imaging, virtual appointments. I've had myself many virtual appointments for medical providers in the last few months, using various kinds of diagnostic tools and surgical tools within the medical arena. This is just the tip of the iceberg. These tools are already available in one form or another, and we can anticipate that there will be many more coming along in the near future. Even in the art world, artificial intelligence has already made its presence known. It's now possible, if you have an image that's in a digital form, you can edit it in various ways. You can edit it in various ways. You can process the images. You can transmit the images. And now there are even tools that are available to be able to recognize images. In fact, again, this is one of the major areas of artificial intelligence tools that are currently on the market, is the ability to process and to generate images. Because I lived most of my professional life in the world of education, I'm very aware of the importance of artificial intelligence tools as they make their way into the educational arena. This is going to be a very big game changer in the not just higher education, but in K through 12 education, whether it's online courses, online degrees, whether it's educational games. We're only beginning to see we're only beginning to see the beginning impact of some of these tools. This list of current technologies that I just mentioned is just a partial list, and characterizes only this, where we are today here in May 2024, and many new AI technologies are going to be coming into these new domains. We say a little bit about science fiction. The area of science fiction is background to artificial intelligence, and the way AI has, for many of us, was first experienced through literature. I've mentioned here, I've just pulled out a few example books, of most of which have some theme to them that deal with, in one form or another, artificial intelligence. One of the wonderful book by Isaac Asimov, I, Robot, was written in the 50s, I believe. Books by Robert Heinlein, Philip K. Dick was a very important science fiction writer. Do Androids Dream of Electric Sheep? For those of you who know the movie Blade Runner, that's the basis for the movie Blade Runner, which is one of my very favorite movie versions that incorporates robotics and artificial intelligence concepts into the film. A few other books that are mentioned here. I just mentioned the last one here, Clara and the Sun, a recent book written by Nobel Prize winner in literature, Kazuo Ishiguro, and it's a wonderful book. Clara and the Sun is about a young girl and her artificial friend at some time in the near future. And it's a book that is one of the most humane books and human-centered books that I have read in a long time, and I strongly recommend it for those of you. It's not long, and it's written in a wonderful style, and it comes highly recommended. So what's going on here? Well, in the last couple of years, you can't, if you read the newspaper or look at the media at all, you can't help but notice that there are many, many news stories, articles, discussion groups having to do with AI. And it's just snowballed. It's come from what was many of us was invisible within the last couple of years. It's now just sort of overwhelming the newscasts. And, to make sense out of that is one of my objectives today. Most of the recent news coverage is about what are called large language models, which is just one version of artificial intelligence. Large language models, sometimes they're called chatbots, because that's what they are. They're kind of, if you will, robots, are non-embodied robots usually, that one can talk with, one can chat with. And that's done by developing a certain kind of a model that processes language and allows humans to interface and communicate in some sense with these devices, these smart machines, if you will, these large language models, sometimes called LLMs. But beyond LLMs, and I'll talk more about large language models more in a minute, but beyond that, there are other kinds of artificial intelligence capabilities that process not text, which is what large language models process, but images, graphics, even videos, even computer code, and other sensing modalities such as touch and feel and so forth. So any kind of sensing mode that can be sensed and processed and communicated can be the basis for developing some sort of artificial intelligence device. And in fact, today, what you find is that most AI devices or AI tools are either a large language model, or they may be in a video model, or another kind of AI tool that only works with computer code, for example. And we're moving very quickly into the area, though, where the various companies that are producing these tools are beginning to combine them into one framework so that they're what you might call multimodal. That is, they do many things. They process text, they process images, they can process graphics, and they can process other sensing information from the vehicle, for example, in the case of self-driving cars. So these multimodal AI developments are just beginning to come into the picture, and one should be on the lookout and recognize them for what they are. Now, multimodal AI developments are much more difficult because they involve multiple modes of operation. And that's why it's so much more difficult to move from something like a large language model that only deals with text to something like a self-driving car, which requires multiple modes of communication and processing of data. In fact, the whole area of robotics, whether it's humanoid robotics or manufacturing robotics or other areas, involve many, many different modes of operation. And these are much more difficult and challenging AI developments to make. Another area that you're beginning to see come into the picture are what people now call co-pilots. I think this is a word that Microsoft currently uses. You can think of these as artificial intelligence personal assistants. That is, they can help humans carry out various multimodal tasks, whether it's making a reservation for a trip to a distant location, whether it's getting dressed, whether it's cooking a meal. One can envision and that at some point in the future there might be these kinds of multimodal AI personal assistants. Again, these three areas right now, self-driving cars, robotics, and personal assistants, are really all in their very much infant stages. These are not existing technologies now that are very advanced, but people are working very hard on them. And certainly there have been much progress made, but if you recognize any of these developments as AI, as being multimodal, that means that they're probably still in their earliest stages of development. One of the things that I might mention is almost all, if not all, of these various AI tools incorporate what are called computational learning tools. The basic idea is that humans provide inputs, whether it's, again, text or images or video or something else. Humans provide input data, which then go into some sort of computational tool, which has the ability to learn and act on and understand in some sense what that input data was, and to then respond to that based on the training that it's had and so forth. And the way this is done is through devices, tools called neural networks. Really, I should say artificial neural networks. This is another way where we have to be careful about the language. Neural networks were originally conceptualized as representing operations within the human brain, but what we're talking about here are what are called artificial neural networks, which indeed were inspired in some sense by real neural networks in the brain, but in fact are very different in terms of the physical way in which they are constructed and the ways in which they operate. We do not understand the cognitive science aspects of the brain well enough to be able to adopt its features, but we do have other ways of incorporating learning tools through what again are referred to as neural networks. Should mention that some AI devices today already can exceed human capabilities on some task. And I'll show you that. I mean, that's obvious if you have played around with any of these tools, but I'll show you some more examples of that later on in a more concrete way. It is important to recognize that this is all new territory in the development of technology. There are many potential benefits of these new technologies. And in fact, people take that as such a given that everyone understands the possible benefits, that people don't often dwell on that as much as they should. But at the same time, there are major risks of these new technologies, as with any technology that we've encountered in the past. And there are people who are very fearful of these risks because they don't understand how these technologies work, and they are afraid that they might do things that they would not be happy with. One of the things that's important is to think of AI, or two areas or two categories of AI. I've called them narrow, and this is the typical language, narrow AI, which are typically the single mode technology, like a large language model, or like an image, or like a language translation model, or like a DALL-E, which is an AI tool that processes images. So distinguish between narrow AI, that is AI that carries out very narrowly focused tasks and has a very narrow area that it presumably understands and can act on. To distinguish that from general AI. General AI currently does not exist. There is no current general AI, although some people talk as if there were. It does not exist now. It is what I referred to earlier as an aspirational hope. And it's what people are working towards. General AI is necessarily multimodal, but it involves much more knowledge, much more data, much more experience, and many more human characteristics that we currently do not know how to, we don't know enough about to incorporate them into these kinds of tools. So general AI is, in a sense, the holy grail that many people are working towards. The problem is that in today's complex world, you often hear people talk about general AI and refer to successes in the world of narrow AI, which in fact does exist, but referring to it as if it were a suggestion for general AI, which, as I've indicated, really does not currently exist in its form. We'll see how that plays out over the next couple of years. People make predictions about when we will have general AI. Almost no one believes we have general AI now, but people's guesses for when it will be available in the future range everywhere from the next couple of years to not for another 100 years or long or beyond that. In some cases, some people believe we'll never have it. Okay, AI, of course, as I've indicated in some of the current smart technologies we already have, does provide benefits to human well-being and human intelligence. It's an add-on to our human intelligence in many ways, and we use tools of various kinds, whether they're physical tools or computer-based tools or some other kind of tool. Tools are important to humans, and this is just another tool. On the other hand, there are plenty of risks. There are potential, I think most of us are aware of the potential for scams and disinformation. That already exists even with the narrow AI tools that we already have. But as those tools expand and become better and more capable, we can anticipate that these tools will be used by bad actors in various ways for their own devious purposes, and we have to be aware of that, and we have to make sure that the companies and corporations that are developing these AI tools work very hard to minimize, if not completely disallow their tools to be used for bad purposes. One of the downsides for these current AI technologies, and for especially the ones that are coming, that's not addressed very often, is that they are energy consumers, big energy consumers. I'll say a little bit more in a little bit about computer data centers, but the cost of many of these AI tools to develop them and to use them is enormous. And only the biggest corporations can be a player in this game. And that's why you see that much of what's being done is being developed by only a few corporate giants in the computing world. One of the things that's gotten a lot of media attention is the idea of existential risk. There are people who have argued that the smart machines will become so smart in the near future that they will take over from humans. Once they become smarter than humans, they will take over for humans and follow their own purposes, no longer being controlled by humans, and that will be an existential end, the end of humanity. I personally think that that's very unlikely. In fact, I think this is a kind of a hype by people often who want you to focus on the long-term risks that may or may not be real, while you ignore the current near-term risks that are absolutely things that are currently concerns, the ones like scams and disinformation, for example. But whether or not existential risk are actually things that we should be concerned about, they at least are things that we should be thinking about as these tools get developed. Finally, the media and hype in all of this is enormous. I've already mentioned that many just a huge amount is written and about these, and people have lots of opinions, both the people working in the field plus people outside the field, not just technologists, but philosophers and lawyers and medical experts. Everybody has an opinion about how this might impact what they know about. And so I think a lot of this hype has generated a lot of fear. And I think, I hope that getting a little bit better insight into all the different features of AI and its potential and risk, perhaps can make it a little less fearful by knowing a little bit more about what the reality is. These are a couple of examples, covers of books, how algorithms create and prevent fake news. Of course, one way of fighting AI and fake news is by using other AI to identify and to essentially alert us to fake news and other kinds of disinformation. And that's being worked on certainly for sure. Fox News has actually been one of the biggest purveyor of existential risk. Experts warn AI could lead to extinction. Well, maybe not. I want to say a little bit about the history of artificial intelligence. It's an area that I happen to have a lot of interest in, partly because my professional life was lived during most of this time period. The first idea of artificial intelligence really came from Alan Turing during the World War II period. He was one of the smartest. He was actually a mathematician, developed computer systems. He was involved in code cracking and for the British during World War II, and he wrote important papers on the areas of what can be computed. And he also developed something called the imitation game, which has to do with how can you tell whether if you're communicating with something, whether it's a machine or a human. And in fact, some of you may remember the relatively recent movie called The Imitation Game that was about Alan Turing. He had a huge impact on the conceptual side of a lot of the things that are being done today. And again, that goes back to the World War II era. But more recently, the fact, again, during my period looking at all of this, much progress has been made since the 1970s. And in fact, during the period 1970 to 2010, a lot of development, and primarily in the academic world in artificial intelligence. Some of the foundations for the concept, some of the ideas of learning and automation were being developed in areas like computer science and engineering, software tools, electronics. Mentioned that in that time period, in the 1980s in particular, several of my students and many, many others worked on a form of artificial intelligence called expert systems. Expert systems take information provided by experts in a certain field, and they encode those some of that knowledge in the form of rules that then are put in a computer system and then used to help make decisions within that domain of knowledge based on the expert rules that have been provided. That was one of the initial approaches to AI. It turned out to work in some very narrow AI fields, but was generally a failure in terms of being able to develop anything like general AI. One of the things that happened during this, again, this 40-year period, a lot of boom and bust cycles. The federal government and industry put a lot of money into research and AI, and it developed some ideas. People got very excited, but then shortly thereafter, they realized that they couldn't really expand those concepts beyond their initial development, and people got very discouraged with AI. So a lot of people went into AI, got out of it, went into it, went out of it, and saw this boom and bust cycle over a long period of time. That's why a lot of people currently are some of us who are a bit older and have seen this remain a bit skeptical as to whether what we're currently seeing, which is really a boom AI cycle, whether it won't be followed shortly by a bust cycle. Well, that remains to be seen, but we'll see. The basic concepts of machine learning and adaptation were developed during this time period, 1970, 2010. The idea of function approximation, that is learning from data about various kinds of information that can be encoded and then used to respond to inquiries or prompts as inputs from a human. That's the basis for all of these tools, machine learning and adaptation. And again, the foundations were developed primarily in academia. But in the 2000 time period, a lot of this changed, and the corporate sector began to get back involved. And since that time, I think it's fair to say that most of the progress in AI has been developed within the corporate sector. And I'll mention a couple of areas here that are particularly interesting. One of the first development successes in AI in the modern version, that is in the 21st century version, was in the area of games. And in particular, you may remember Deep Blue, which was an IBM computer system, was taught to play chess and was developed. A lot of effort went into the development of this chess playing AI. And in fact, it became a world champion and beat Kasparov, who had been the human world champion up to that time. And now chess, the best chess, computer playing chess devices can beat any human. And just a side remark about that, one might expect that would have meant that chess was not very interesting to people anymore. And that's actually wrong. People continue to be engaged by chess. In fact, chess is as popular as ever, demonstrating that just because machines can look ahead many more steps than any human can, and therefore they can ultimately win in a chess game, humans still feel challenged and intellectually stimulated by a game like chess. Another game that's very important to many people throughout the world is the game of Go. Game of Go is a very simple game, very popular, especially in Asia. And I want to mention that there were important AI developments in developing a Go playing computer by a company called DeepMind. The name of the AI device they developed was called AlphaGo. And in the tight 2016, 2014 time period, AlphaGo was challenged the world champion Go player at that time, whose name was Lee Sedol, and there was a playoff, and I think it was Singapore, or maybe it was Korea, and a major development at that time, and the outcome was 4 games out of 5. 4 out of 5 of the games were won by the machine. And this was a major turning point in a lot of people believing that, at least in the area of narrow AI, in this particular instance, a game, that in fact computers could really perform at a high level, in fact, higher than humans. Just an aside on this, I would highly recommend that if you're interested, you watch a documentary that's available on YouTube. It's called AlphaGo. It's about a 2-hour documentary of the history of that development technology and the games that were the games that were played. And it's very well done and is available for free on YouTube. Another important development in the area of imaging was DALL-E in this 2016 time period, which processed not text, but imaging. I should have said that the game playing AI tools, they were actually planning tools. That is, they look ahead, the number of moves, and they do planning and strategy. So they're not text, they're not large language models. They're totally different. And they don't process images. They do strategizing. But the imaging AI was developed about 8 years ago. Was the first big one was DALL-E, which was a major step forward in image processing. At the same time, voice communication was improving enormously. And one of the holy grails of AI since I was a graduate student had been automatic language translation. And during this time period, again, about 10 years ago or so, finally, these tools became powerful enough that language translation, major advances were made in language translation. That is, automatic translation of a human language or a computer language from one language to another. And this is now, if not a completely solved set of problems, at least we have tools that are tremendously useful for language translation now. Biomedical developments were also being studied and have been studied for some time. One of the first successes was a kind of not a medical advance, but an advance in the area of basic science, protein folding within a gene. It's a very complicated geometric problem, and AlphaFold was an AI tool that was developed to do this automatically. Again, far beyond what any human could do, but it provided a solution to a problem that was very important in the world of genetics. 2012 was the period when the birth of modern AI occurred in the minds of many of us. the advances I just alluded to occurred, but also there were some three things that came together that really led to a major jump in advances in AI. Those three areas, those advances were in three different areas. These AI tools primarily consist of three components. They consist of some sort of learning machine or neural network. That's one. They also consist of data. You have to have a lot of data to train these neural networks on. And so just having enough data and being able to handle big amounts of data is an important one. And then the third and last, but equally important, is you have to have the physical hardware, the physical stuff on which these neural networks and data are operated on. That is, you have to have something physical that actually embodies these kind of conceptual devices, and that's electronics. And electronics were being developed, advances over the years, very important in the world of computing technologies. What had been used were what were called CPUs, computing processing units. Those are the basic units that carry out the computations on your smartphone or on your laptop or on your desktop. Those electronic components, however, weren't really tailored to do the kinds of computations that were necessary for AI. And that was a stumbling block for a long time. And it's a very interesting story about how the electronics that were made for game playing, you may remember back in the early 2000s, electronic games were a major area. And they were using a special kind of computer chip called GPUs, or graphics processing units. And it turned out that the technology developed for game playing computers some 20 years ago, it turned out to be exactly what was necessary for use in AI devices. And so these advances in neural networks, in electronics, in GPUs, and in data, and large amounts of data, and being able to handle and process it, all came together. Those are the three ingredients that led to this birth of the modern AI that we're now seeing today. The words that people use to describe the coming together of these areas is convergence and scaling. Convergence meaning that all of the ingredients that were necessary to make very advanced narrow AI now were in hand in this time period around 2012. They were now in hand and could be brought together to do something that none of these tools alone were capable of doing. And the scaling is important because although some of these tools had been put together in the past, that is data, neural networks, and electronics, these tools have been put together before. They were dealing with small amounts of data, small computing requirements. By small, I mean maybe, images for if you're processing image, maybe 100 images, maybe 1,000 images, but not millions of images. And it was only in this relatively recent past that we were able to scale up so that we were able to handle things like large amounts of data, large numbers of images, complex data, and to have access to that data and be able to process it in various ways. We've seen the result of that in the last couple of years, release of AI products, a couple of different major players here. OpenAI, which is a company that is very much in the news today, primarily in the area of large language models or chatbots, and they produce ChatGPT. Their recent development, an extension released a few days ago, GPT-4o or GPT-4, and Sora, which is a multimodal version of their AI that will be coming out soon. Google is a big player here. It's had a number of different AI tools, and in fact, AlphaGo and AlphaFold were developed by a company called DeepMind, which was bought out and is now a part of Google. Facebook, or Meta, has its own projects underway, and their current large language model is called Llama. And these are just examples. And there are many other companies that are now developing, not many, but there are other companies that are developing their own AI products. I should say that to develop a full-fledged AI large language models requires on the order of an investment of approximately $1 billion. That's a billion with a B. And that's why only the biggest companies are involved in doing this. In fact, the current corporate leaders, DeepMind, again, DeepMind being part of Google, OpenAI, Microsoft, Meta, big player. Anthropic is an important player. It's a spinoff from OpenAI. You may have, well, Amazon is a big player, and perhaps the biggest player today is NVIDIA. NVIDIA is the company that makes many of the computer chips, the GPUs that I mentioned earlier. They were originally in the game, making chips for computer games, and now they're big time into making chips, electronic chips for AI. The products that we're seeing come out, they're both end user AIs that are end user apps. So we see some apps that are labeled AI, and you see an app up here. This is the ChatGPT logo up here that shows that you often see, and it's just an interface if you want to use their AI. But you're also seeing other tools where AI is embedded in those user apps, and so AI will again be becoming, it will occur both in a standalone form, but also as a part of an embedded system as well. This is my one slide about technology, really. I said there are 3 aspects that are the key to the technological developments here. Let me take just a couple of minutes to say a few words about that. First is the neural network. The neural network is the AI brain, if you will. It's basically a structured connection of neurons. And this image in the upper right-hand side is the circles denote neurons, which simply do nothing more than a simple computation, like a multiplication or some other simple numerical computation. And they're connected together through lines, and that's what makes the network structure. And you notice that there are several different layers that you see, and this is the characteristic of a neural network. And the input data that you have is tokenized, that is digitized into a form, basically bits, zeros and ones, that are then fed into the neural network on the left-hand side, and then it's processed by each node, and then goes to the next node, the next layer, excuse me, and it's processed by those nodes in turn, and so forth, all the way to the end. And at the end, you get an output set of tokens that is your answer or your response from the neural network. Now, the question is, how does this complex network encode and learn something meaningful? The way it does that is that each one of these circles has a parameter associated with it, usually just one parameter. And that parameter, it gets adjusted so that the output best fits the kind of responses that it's trained upon from the data that's fed into it from the left. And so these neural networks we call them training. They're trained, that is, they are learned to adjust, they're learned, which means that their parameters are adjusted to give you output responses that are suitable and meaningful for the kind of inputs that they received on the left. And so that's basically the idea in a nutshell of a neural network. This is a kind of a graphical picture of what they do. There are various bells and whistles that are added: generative, pre-trained transformers. That's what the words GPT refer to. Generative means that you can take text, for example, in a large language models, and the response to the text is a kind of a continuation of that text, and it's that response that is generated, and this device can in principle do that kind of generation of responses based upon the neural network that you have. Pre-trained means that the parameters in this neural network are adjusted to give a good fit that is, they're trained from existing data. But you have to have good data, you have to have meaningful data that provides learning for the ability for the network to learn. And transformers is basically a technology to speed up this process. But that's what a neural network does, and this is software. That is, this doesn't exist in reality. This is just a concept, or it's like a program, if you will, a computer program, but it has to be embodied in physical electronics, and that's the electronics at the bottom here. In fact, I've given just a close-up picture of an example of a GPU. This is a very small little device, maybe an inch on the side, and it processes bits, electrons coming in and going out, and it processes them in particular ways according to the neural network. And these things are put together in racks and racks and assemblies that are huge. This is an example, a picture of a data center. Below it, just an example to show you. And these data centers are enormous factories of electronics that are required to train these neural networks and to be useful and as an AI. And of course, the data, I should have mentioned, the data could be text, images, video, audio, computer code, or something else. And basically, you need huge amounts of data. And that's why this is such an expensive proposition, because you have to train the neural network, train the AI on lots of data. And you've got to get lots of data. And where do you get lots of data? Mostly from the internet. The operational issues, just a word about that. The electronics carry out the computations on the input tokens according to the specifications of the neural network. If input is viewed as sequences of tokens, then the output is a prediction or a generation of the next token. And in fact, that in its simplest form, it is appropriate for you to think of what's going on here as a very much more advanced idea of auto completion in a word processor. In a word processor, if I type in the word SOM, if I type in on my word processor SOM, it's probably going to add the word E at the end. Why? Because the probability of E being on the end of that is so much greater than any other letter that it's going to auto-complete that for me. Now, I can change it if I want, but that completion is basically done on a statistical basis. And that's exactly the same kind of thing that these neural networks are doing, although in a much, much, much more sophisticated way. There are two operational stages to keep in mind. One is the training, that is, the neural networks have to be trained on data. And this is, as I've already mentioned, a computationally intensive problem. And this is what takes a long time, takes a lot of investment of electronics to do this. And it's why things are very expensive. But the inference stage, at the stage of where the user comes into the picture, from the user's point of view, you never see the training. You see an AI that's already been trained. So when you're using an AI, you don't see any of that stuff. It's all hidden under the hood. What you see as a user is that you want to use this as, to make an inference. You ask a question, you ask a prompt, and what you want is for it to respond to you in some meaningful way. That process is called inference. And at that stage, the neural network, the pre-trained model, and the input prompts that you provide from the user are used to generate AI output. And that process, that inference step, is very quick, very, very fast, and relatively, and it's not energy intensive. It uses relatively little compute power to do that. So the training is where all the complexity and the expense is. The inference step, which is where the user gets involved, is usually pretty simple and pretty. But of course, if the neural network wasn't properly trained and developed properly, then it wouldn't provide. It would be garbage. You'd be you'd put some input and you'd garbage output. There are a lot of opportunities for future AIs. I'm not going to go through much of this. Investments, automated transportation systems, brains for autonomous robots. Sometimes people call this the Internet of Things. Creation of new materials, genetically tailored drugs. In the art world, areas of poetry, fiction, nonfiction, art, music, dance, programming, coding with natural language. Really, it's fair to say that all academic disciplines and all really intellectual fields are at least potentially going to be influenced, if not transformed, by these, I think, future developments. Even if we never get general AI, narrow AI still can do enormous numbers of things. The two images I have here are just some University of Michigan future AI developments that I wanted to mention. One is a walking robot. This one is Mabel here in a walking robotics lab. And this other one is a picture of a little vehicle that's been running around the University of Michigan campus and around Detroit. It's called May Mobility, and it's a self-driving vehicle, if you will, a self-driving taxi. And it's been running around Ann Arbor streets for several years. An area that I want to say a little bit about has to do with humans and machine intelligence. I've used the word in machine intelligence, artificial intelligence. How does that relate to human intelligence? And I think, we're using, again, language here, intelligence, that we didn't used to do this, 30, 40 years ago much. The word intelligence never had the modifier machine in front of it. It was intelligence was only, even animals we didn't think of as intelligent. We thought of only humans having intelligence. I think today it's fair to say that we see things in a very different way, and that we realize that intelligence can be exhibited in a lot of different ways by animals of various kinds. Certainly things like dogs and cats and elephants and whales and dolphins and so forth, but also lower animals, insects, even single, even relatively simple animals. And now, if you study closely, scientists have realized that they have the ability to often process information in ways that we might call intelligence at some level. Ideas of sensing, the characteristics of intelligence, sensing, memory, pattern recognition, learning, prediction. These are all things that we think of as human characteristics, but they also can be, and these words are being used for machine and animal characteristics as well. Words that are a little bit more, have a little bit more baggage associated with them. Words like creativity, self-awareness, emotions, consciousness. Those are words that many of us still reserve sort of for humans, but at the same time, it's certainly arguable that what we're seeing in terms of some of the machines that AI tools that have been developed exhibit things that seem very much like creativity, some level of self-awareness, some kinds of emotions at some level, some consciousness. People argue about this a lot these days. What is consciousness? I mean, I'm not sure exactly what human consciousness is, much less what machine consciousness is. Going back to Alan Turing's idea of an intelligence test, the so-called Turing test, turns out that many machines now pass the Turing test. That is, you can have a conversation with something behind a curtain, and depending upon how far the conversation roams over what kind of topics, you will probably not be able to tell the difference between a machine, a well-trained machine, and a human. As I said, machines already are much more knowledgeable about a lot of things than some humans are in some areas of knowledge. And so machines already passed the Turing test. Machines already also perform at the very highest level on intelligence tests of various kinds. The Scholastic Aptitude Test, the Law School Aptitude Test, the MCATs, and others. There are machines that have done, in the 90th, 95% percentile performance on those tests. There's a word that sometimes people use. The word is called emergence. The idea of AI intelligence. What is the evidence for intelligence? Emergence is when what comes out of these AI tools is unexpected, is beyond what you would have anticipated, knowing what the tools are and how they were trained. That idea of emergence is something that has occurred over and over again in various applications and various AI tools. And in fact, AlphaGo, if you were to watch the movie AlphaGo, there is a point in the game at which the machine plays a move, makes a go move that everyone at the time, and Lisa Dahl, the human he was playing against, the machine was playing against, thought at first was stupid and silly and wrong. But after a few moments had elapsed, they realized that the move that the machine had made in Go was not like a move any human would ever make. It was beyond what humans could process. And it turned out to be the winning strategy in the game. That's an example of emergence. And that's occurred in an obvious way in that particular game, but it occurs regularly in lots of other areas of AI application. So that's the kind of evidence that people use today to argue that machines do exhibit intelligence. One of the problems that we have is that we are using, again, language in ways for which it was not originally intended. It would be nice if we understood the way human intelligence worked, and that's referred to in philosophical circles as a theory of mind. Cognitive scientists, philosophers, and others have been working to develop a theory of the mind, the way the brain works, the way the mind works. To be honest, they've not been very successful at that. We still are at the infancy and understanding the scientific aspects of the brain and the mind. In fact, we're not even sure if the mind and the brain are the same. People argue that the mind is just an encoding of the brain. Others argue that there's something more spiritual about the mind. This is an important theoretical and philosophical issue, but it's also a practical issue. Turns out that when you train AIs, you can train them in various ways to be more creative or less creative. That has to do with the way you train the parameters in the neural network. And you can make them more creative or less creative. Guess what? If you make them more creative, they can make these fantastic leaps, these steps that humans would never see. On the other hand, they often make some leaps that humans would never make because they're stupid or they're dumb. And that's what we call machine hallucination. And that's a problem. That's where disinformation can come from, and other kinds of problems. So we have the ability to make a trade-off in defining an AI between how creative it is and to make it and how hallucinogenic it is. And in fact, you know, if you want to have no hallucinations, you can do that. You can make AIs that do that. They'll never be wrong, but they won't be creative. They won't be interesting. They won't provide any beyond the box thinking. So this is and we don't know how to solve that problem. These are philosophical questions that are really much beyond technology, and they require input from philosophers and cognitive scientists and others. And unfortunately, they are helpful, but they're not. They don't know. They haven't solved these questions. Another factor that makes this all more complicated is that the complexity of these neural networks are such that, by and large, as humans, we cannot really understand what they're doing, why they make certain responses and why they don't make other responses. We don't really understand that. They're trained on so much data. Their neural network is complicated enough that to us, it's like a black box. We don't understand how they work. And that's a problem for us because we would love to understand that as humans, we'd love to understand how they give us these responses. But right now, we really don't have a good handle on that. A lot of issues about AI ethics and the alignment problem. The alignment problem is the problem that AI developers have to design their AI tool to align its objectives with human objectives, to make those, to make their kind of core essence be the same, that they have the same value system, they have the same objectives, to make the AI align with human values. But there are a lot of problems with that. First, humans don't all have the same objectives and goals. Second thing is that AI devices often go far beyond, they know much more than any human can possibly know. Sometimes we call that super intelligence, where AI knows more than any one human, or even more than all humans. The point where at the level of general intelligence, and I've already said multiple times, we are not at general intelligence right now. We are working on narrow AI. But at the level of general artificial intelligence, when AIs will be smarter than all humans, the point at which that occurs at the general intelligence level, sometimes people refer to as the singularity, because humans will then be completely at the mercy, if you will, of the machines. But again, that's a hypothetical, that's an existential question, and I don't think it's one that is currently anywhere worth being too concerned about. One of the things that some of the corporations, Anthropic, I mentioned as a company earlier, it worries very much about ethics issues. It actually builds into its tools AI constitutions built around equity, privacy, copyright, goal alignment, and so forth. So these issues are being developed, are being thought about very much by some corporations, but not so much by other corporations. Some corporations take some of these ethics issues seriously. Others are more interested in the marketplace. Implications for machine intelligence. I think we've covered most of this. Misaligned subgoals, misinformation, hallucinations, digital fakes, biased neural networks, biased data. Obviously, if you use biased data in your training, you're going to get biased AI. Malevolent human users, scams, adverse effects on human employment and human well-being. I haven't said very much about that, but that's obviously a very important subject to be discussed and thought about and perhaps planned for. There are governments who beginning to get involved in this. The European community is far ahead of the United States in developing and regulating artificial intelligence. There are different ways to do this using what are called by some guardrails. You can use technology to say, well, you can't go into certain areas, you can't do this. Some people want to regulate kind of the way the neural networks are constructed. Other people only want to regulate and put guardrails up for the responses. There are different ways to do this. There's no one way to do it, and it's not clear what the best way to do it is. Do you regulate the research? Do you regulate only the products? How's this constitution idea? How does it fit into this? So anyway, corporate and government regulation we're right in the middle of all that. I think as citizens, we need to take an interest in that. As I said, the European community already has in place just recently some new tools. The Biden administration has recently released some documents about what they think should be the general framework, although they are not very specific. But also, China's a big player in this. And of course, China is developing its own AI tools based on its own approach to things, approach to things like privacy and centralization and so forth. There are a lot of global issues, global politics that come into this. And these are very complicated. And we're going to have lots of problems at the policy level and at the government level in terms of making our way to get the benefits of AI without the downside risk. This is just their final slide up here. This is I think this was in the New York Times. These are just some images of humans. And some of these humans are generated by AI, and some of the humans are generated by are just photographs. You can ask, well, which are which? And I think, let me get this right. I think this is right. The Times did a lot of testing of people, but people they did 50%. It's like guessing. It's hard to tell. But the images in the upper right are the humans. The ones in the images in the upper level are the humans. The ones in the lower level are the AI. But anyway, this is just an example, kind of a toy task to try. There are a number of opportunities for any of you to have even a smartphone to go on and try an AI tool for free, just as a one-time thing. Go to openai.com, for example, or other places. Just search on AI tools, look for free tools, and it's easy to set that up. And there are a few people around the Glacier Hills community who have been doing this and perhaps can help you. I'm happy to act as a consultant if that's useful. A couple of final thoughts here, and then I'll end this. A couple of things about technology in general. A couple of phrases that I've always found useful that I think are relevant to AI. One is that any advanced technology is indistinguishable from magic. And so for many of us, these AI tools, they really seem magical. I mean, well, they are magic. I mean, after all, magic is itself something. It's a thing which it's just that we don't understand it necessarily, how the trick was done, but there is a trick behind magic. And in AI technology, it seems even more, it goes far beyond just the idea to, make something disappear or to, anyway. But anyway, I think that's an interesting quote. So if you think of AI as magic, it makes perfect sense to think of it in that way. The other quote is the humans oversell the short-term benefits while underestimating the long-term benefits. And I think that makes a lot of sense. I think a lot of the current hype is oversell. People are, they're investors. There are corporate hucksters. A lot of people selling AI now. I think that it's being oversold myself at the current time, but at the same time, I think these are real developments. They're important, and they're going to have some long-term benefits, and I hope not too many long-term risks. And I've already mentioned the boom and bust cycle about AI, and I would not be surprised if, with all the recent hype we've had in the last few years, we wouldn't see some kind of a backlash against AI in the next year or so. So my recommended perspective on artificial intelligence is, and this is the way I kind of look at things, I'm excited about the developments. I think it's exciting to live at a time in which these kinds of concepts, both at a scientific level, but also at the level of human relationships and human knowledge, are being developed in ways which go far beyond what I would have ever imagined, certainly just 20, 30 years ago. At the same time, we need to be cautious, and we need to be a bit skeptical about the hype that is being produced. And I think sometimes it's certainly wise to step back and say, well, let's just wait and see. But the main thing I would suggest is that we not be fearful. I mean, we've seen in our lives so many changes over the years, not just changes in technology, but changes in, world relationships and human relationships and knowledge. In so many different areas. That's one of the things that we've tried to learn, is to adjust over our lifetimes to all these changes and the rapidity with which they occur. And I personally think of AI as just a continuation of that major world of changes. And as I said a minute ago, I'm delighted to have had at least a chance to be alive to see some of these developments. That's my attitude, to look forward towards the excitement that they create without being fearful of them. I thank you for staying with me. If you're still watching this, I've enjoyed studying these subject areas, and I've enjoyed sharing them with you. And I wish you all the best in terms of your trying to come to grips with some of these exciting developments.